The National Electrical Code, or NEC, does permit the use of cable trays within the United States, but adhering to specific conditions is a must. Article 392.1 states that cable trays must be listed and must possess adequate strength and rigidity to endure the weight of the cables they support. Article 392.3b mandates that cables installed in cable trays need to be secured to the tray, preventing any physical damage. Article 392.3 indicates that cables installed in cable trays should be grouped and bundled in an orderly fashion. Article 392.5 requires cable trays to have suitable covers to prevent physical damage to the cables. Article 392.6 dictates that cable trays must be installed in a way that provides adequate support and protection against physical damage. Regarding greenhouse installations, the proposed installation method appears to align with the NEC requirements for cable tray installations. Firstly, a listed cable tray is being utilized. Secondly, the cables are secured to the tray to prevent damage. Thirdly, the cables are grouped and bundled appropriately. Fourthly, the cable tray has suitable covers. And fifthly, the cable tray is installed to provide ample support and protection. Apart from the NEC standards, local codes or regulations could influence cable tray use in a specific location. Consulting with the local authority having jurisdiction, known as AHJ, is always recommended to ensure compliance. Cable tray installations offer several advantages over conventional conduit and individual conductor wiring methods. These include, firstly, reduced labor costs due to faster installation time. Secondly, improved cable management and accessibility for future changes or maintenance. And thirdly, enhanced safety by protecting cables from physical damage. Based on NEC requirements, the proposed cable tray installation method is likely permissible in the United States. However, consulting with the local AHJ is still advised for confirmation. Cable trays must adhere to Article 392 of the National Electrical Code. The NEC defines a cable tray system as a unit or assembly of units or sections and associated fittings forming a structural system used to securely fasten or support cables in raceways. Cable tray systems include ladders, troughs, channels, solid bottom trays, and other similar structures. Cable trays provide a versatile support system for various types of cables, including power cables, control cables, instrumentation cables, and communication cables. Cable trays are typically made of metal, such as steel or aluminum, or non-metallic materials, such as fiberglass reinforced plastic. Choice of material depends on the specific application and environmental conditions. Cable trays offer several advantages over traditional conduit systems, including ease of installation, flexibility in routing cables, and improved heat dissipation. Cable trays are commonly used in industrial facilities, commercial buildings, and other applications where a large number of cables need to be supported and managed. The NEC specifies requirements for the design, installation, and use of cable tray systems. These requirements are intended to ensure the safety and reliability of electrical systems. Article 392.2 provides definitions relevant to cable tray systems. These definitions include terms such as cable tray, ventilated cable tray, solid bottom cable tray, and single rail cable tray. The NEC defines a cable tray as a unit or assembly of units or sections and associated fittings forming a structural system used to securely fasten or support cables and raceways. A ventilated cable tray is a tray with openings in the bottom or sides to allow for air circulation. A solid bottom cable tray is a tray without openings in the bottom. A single rail cable tray is a tray consisting of a single rail with brackets or supports for cables. Article 392.3 covers uses permitted for cable trays. Cable tray systems are permitted to be used for the support of various types of cables, including single conductor cables, multi-conductor cables, and optical fiber cables. Cable trays are permitted to be installed in various locations, including indoors, outdoors, and in hazardous locations. Cable trays are permitted to be used in wet locations if they are identified for use in such locations. Article 392.4 covers uses not permitted for cable trays. Cable tray systems are not permitted to be used as a substitute for raceways for conductors that are required to be enclosed in a raceway. Cable trays are not permitted to be used to support equipment or other non-cable items. Cable trays are not permitted to be installed in hoiseways or elevator shafts. Article 392.6 provides requirements for the installation of cable trays. Cable trays must be installed as a complete system. Cable trays must be securely fastened to the building structure or other support. Cable trays must be installed in a manner that prevents physical damage to the cables. Cable trays must be installed in a manner that allows for access to the cables for maintenance and repair. Article 392.7 provides requirements for granting and bonding of cable trays. Cable trays must be granted in accordance with Article 250 of the NEC. Cable trays must be bonded together to form a continuous electrical path. Cable trays must be bonded to other metal parts of the electrical system. Article 392.8 provides requirements for cable installation in cable trays. Cables must be installed in cable trays in a neat and workmanlike manner. Cables must be supported at intervals that prevent excessive sag. Cables must be protected from physical damage. Cables must be identified in accordance with Article 310 of the NEC. Article 392.9 provides requirements for allowable cable fill in cable trays. The NEC specifies the maximum number of cables that are permitted to be installed in a cable tray. The allowable cable fill depends on the type of cable tray, the size of the cables, and the ampacity of the cables. Article 392.10 provides requirements for cable splices in cable trays. Cable splices are permitted to be made in cable trays if they are made in accordance with Article 314 of the NEC. Cable splices must be accessible for inspection and maintenance. Cable splices must be protected from physical damage. Article 392.11 provides requirements for cable terminations in cable trays. Cable terminations are permitted to be made in cable trays if they are made in accordance with Article 314 of the NEC. Cable terminations must be accessible for inspection and maintenance. Cable terminations must be protected from physical damage. Article 392.20 provides requirements for cable tray construction. Cable trays must be made of metal or non-metallic materials that are suitable for the intended use. Cable trays must be designed and constructed to withstand the loads that will be imposed on them. Cable trays must be protected from corrosion. Article 392.22 provides requirements for cable tray marking. Cable trays must be marked with the manufacturer's name or trademark, the cable tray type, and the maximum load rating. The NEC provides specific requirements for the types of cables that are permitted to be installed in cable trays. These requirements are intended to ensure that the cables are suitable for the environment in which they are installed and that they are properly protected from damage. The NEC also provides requirements for the ampacity of cables installed in cable trays. The ampacity of a cable is the maximum amount of current that the cable can safely carry. The ampacity of a cable depends on the size of the cable, the type of insulation, and the ambient temperature. The NEC provides tables that specify the ampacity of various types of cables. When installing cables in cable trays, it is important to ensure that the cables are properly supported and secured. Cables should be supported at intervals that prevent excessive sag. Cables should be secured to the cable tray using cable ties or other approved methods. It is also important to ensure that the cables are protected from physical damage. Cables should be routed in a manner that prevents them from being pinched or crushed. Cables should be protected from sharp edges and other potential hazards. When making cable splices or terminations in cable trays, it is important to follow the manufacturer's instructions. Cable splices and terminations should be made in a manner that ensures a reliable electrical connection. Cable splices and terminations should be protected from physical damage. When working with cable tray systems, it is important to follow all applicable safety precautions. Always to energize the electrical system before working on it. Wear appropriate personal protective equipment, such as gloves and safety glasses. Use caution when working with tools and equipment. Cable trays offer a flexible and efficient solution for managing and supporting electrical cables in various applications. Understanding and adhering to the NEC requirements for cable tray systems is crucial for ensuring the safety and reliability of electrical installations. Cable trays offer significant advantages in greenhouse electrical and control wiring. The use of cable trays can lead to a reduction in labor costs. The speed of installation is a major factor. Installing cables in trays is generally faster than running individual conduits. Cable trays offer better cable management. They allow for easy identification and tracing of cables, which simplifies maintenance and troubleshooting. Cable trays are easily accessible. This makes it simpler to add, remove, or reroute cables as needed. This is especially beneficial in dynamic environments like greenhouses. Cable trays enhance safety. Cables are protected from physical damage, reducing the risk of electrical hazards. The NEC Article 392, which covers cable trays, provides a comprehensive set of guidelines for their installation and use. Key aspects of Article 392 include support and securing. Cables must be adequately supported within the tray to prevent sagging or strain. Proper securing methods, such as cable ties or clamps, should be used. Grounding and bonding. Cable trays must be properly grounded and bonded to ensure electrical safety. This helps to minimize the risk of electrical shock and equipment damage. Fill capacity. The NEC specifies the allowable cable fill for cable trays. It is essential to adhere to these limits to prevent overheating and ensure proper ventilation. Physical protection. Cable trays should be installed in locations where they are not susceptible to physical damage. If necessary, additional protection should be provided. Proper labeling. Cables and cable trays should be clearly labeled to facilitate identification and maintenance. Considerations for greenhouse environments include moisture and corrosion. Greenhouses often have high humidity levels, which can lead to corrosion. It is important to use cable trays and cables that are specifically designed for wet or damp locations. Chemical exposure. Greenhouses may also expose electrical systems to chemicals used for pest control or fertilization. Selecting cables and trays that are resistant to these chemicals is crucial. Temperature variations. Greenhouses can experience significant temperature variations. Electrical components should be able to withstand these fluctuations without degradation. Compliance with local codes and standards is a must. In addition to the NEC, local codes and standards may apply to greenhouse electrical systems. It is important to consult with the local AHA to ensure compliance. By following these guidelines, the advantages of cable trays can be realized while maintaining a safe and compliant electrical system. Remember that regular inspections and maintenance are essential for ensuring the long-term reliability of greenhouse electrical systems. This includes checking for signs of corrosion, damage, or overloading. Any issues should be addressed promptly to prevent potential problems. The transition from traditional conduit systems to cable tray systems requires a thorough understanding of the NEC and local codes. Proper planning and design are essential for a successful installation. Investing in high-quality materials and workmanship will pay off in the long run by reducing maintenance costs and improving the overall reliability of the system. Cable trays are a viable and advantageous option for greenhouse electrical wiring when installed in accordance with the NEC and local codes. Their use can lead to improved efficiency, safety, and flexibility.